let's give this another go. Alright, so Geometry B, hello. So what we're going to do today is we are going to talk about the properties of parallelograms. Right? So hopefully so far you've taken a look through Miss KB's video on the family tree for different types of quadrilaterals, and you've also watched the other video on the 7 different types of quadrilaterals. Right? We're going to be talking a little bit more about parallelograms, and we're going to link these things a little bit more into, a little bit of that stuff that you've done in the past. So one of the first things we got to talk about are these properties of parallelograms, right? So we've got a couple of them, and they're all pretty important. So there is one that's not listed here that, is kind of already like a duh thing about parallelograms. They have 2 pairs of parallel sides, right? That's something that we've talked about before. That's something that all parallelograms have, right? But these are some extra special properties that are a little bit harder to see from just a diagram. So we're going to say is that in any parallelogram, right, any possible parallelogram you might have, the opposite sides are going to be congruent, right? Those opposite sides are going to be the exact same size as one another, right? They're going to have the same measure. You can also do the same thing for the opposite angles, right? If you have 2 angles that are across from each other in a parallelogram, they're also going to be congruent. We have that the consecutive angles are supplementary, right? Consecutive just meaning that you would run into one right after the first one. And supplementary meaning that they add to 180 degrees. Right? That might not be something that you've seen in a little while. Right? But supplementary is that they add to 180 degrees. Last but not least, we know that the diagonals bisect each other. Right? So we talked a little bit when we were defining the different types of quadrilaterals about what a diagonal is. Right? So say I just drew out some sort of shape like that. Right? A diagonal is something that goes from one vertex, right? Say I went from here, and it goes to a non-adjacent vertex, right? So that would be a diagonal there. I can make a diagonal from there to over there. I could make this diagonal here, right? But specifically in a parallelogram, the diagonals cut each other in half, right? So they're going to meet in the middle, and where they meet, each one is going to have half of its length on one side of that intersection and half its length on the other side. All right, cool. So that's really the bulk of the important stuff. What we're going to do is we're going to focus on how to solve problems with those properties. So this first one here, right, it's given us a parallelogram. It's got some information that's marked up on it and all that good stuff. And what we're going to do first is we're going to try and figure out what FM is. All right, so FM is a type of radio. No, just kidding. So FM is right there. So what I'm seeing and what I'm kind of thinking through as I'm trying to approach this problem is that MF, or FM, is part of a diagonal, right? In fact, it's part of this diagonal with its other piece in the pink there. Right? What I know, because we're told that this is a parallelogram, is that the diagonals are bisected when they meet in the middle. So if I know that that pink side is 5, that means that FM also has to be 5, right? Because it's bisected. It's bisected, which means that it's cut directly in half. There's half of its length in the pink and half of its length in the yellow, so those pieces have to be the same. All right, cool. Easy as pie. Huh? Get it? Because pi, like the math pi. Okay, whatever. So, the other piece we've got, we're trying to find HT. Right, so HT is a side of this parallelogram. And what I'm kind of taking a look at is that I'm looking and saying, all right, I know that the opposite sides of a parallelogram have to be the same size. So if I take a look right across the way, right, AM is an opposite side to HT. Right, so because AM is 8, that means that HT is also going to be 8. Right, that's really all we got to do for those. Right, we're just using those properties. We're going to talk a little bit about some problems with some angles. Right, so I've got the angle MAT is the one we're looking for. Right, so it's that angle that's kind of in that corner of the parallelogram. Right, it's that entire piece right over there. And if I'm trying to figure that one out, right, I know that the opposite angles in a parallelogram are congruent. So if I take a look across, I know that that whole angle in that other corner is 80 degrees. Right, these are opposite from one another, so they're going to have the same measure. Cool. That's it for that one. Last but not least, we're looking for angle HMA, this angle up in the top there. Right? So the last property that we haven't really used yet is the fact that the consecutive angles are supplementary. Right? So what that means is that, we just use that angle down by H, right? We used that 80-degree angle on the last one. We can do the same thing here. We can use that. So because that pink angle and the yellow angle come one right after the other, like as I'm kind of walking my way around the parallelogram, they are consecutive. So what that means is that if I know that that one's 80, that one up top is going to have to be 100 degrees, right? Because I have to add to 180. If I've got 80 of it, I need another 100 to get the rest of the way. Right? That's all we're really doing with those, right? We're just using the properties and saying like, all right, what information do I have? How could I set things up? What do I need? All right, let's try another couple out. We've got that we're looking for AO. Right? So to find AO, right, again, just like on the last one, it's part of a diagonal. The other half of that diagonal is from L to O. Right, so if LO is 6.5, that means that AO also is going to end up being 6.5, right, because we're bisecting the diagonals. To get PL up on the top, right, what I'm going to do is I'm going to take a look and say, all right, do I have an opposite side? And sure as heck I do. From A to R is 15, right? So because those are opposite sides from each other, they're going to have to match as well. Sweet, halfway there. Now we're looking for angle ARL. Right, that's this angle down in this corner here. And, you know, when we have an angle, what we want to do is we want to say, all right, do I have the angle that's opposite from it, right? So I'd be looking up there, because that's the easy one, right? If you have the angle that's opposite from it, you just say like, oh, yep, it's that, cool, we're done. In this case, I don't have that though. Right? So if you don't have an opposite angle, take a look and see if you have a consecutive angle. And I sure do. I got 120 degrees right there. So what I'm going to do is I'm saying, all right, that yellow angle and that pink angle have to add up to 180. Right? I know that I have 120 of it, so I know I'm going to need 60. Right? If you're a little bit, confused about how to get that, we can always also do, so we can take 180. We can take away that pink angle that we know about. Right? So say the numbers don't work out as nicely. Right? And we can get 60 degrees that way for that yellow angle. Right? Because if they have to add to 180, I can say 180 minus the chunk I have will give me what's missing. All right, cool. Last but not least, we're looking for RLP, which is the angle up in that corner. We use a different color since we're using the yellow and the pink already. If I'm looking for that angle up there, right, again, first thing I would do is I would take a look and say, all right, do I have an opposite angle? Sure do. The opposite angles are going to be the same, so we can call that 120 degrees. Cool, so all those are already set. All right, hopefully it doesn't seem too bad. So you might have been taking a look at the bottom of the page there and freaking out about like, oh my god, there's variables. Right, they're not going to be that much worse. Right, I did add these on, so these may not be something that entirely matches what the filled in notes have, so I might take a little bit closer look at these ones. I did want to make sure that we talked through some examples of these ones where there are variables floating around, because cough, cough, these might be ones, that's not an actual cough, I'm not sick. Right, these might be ones that you will be asked to do later. Right. So what we're given is that AE is 2x plus 2, and EC is 4x minus 8. All right, so 2x plus 2 in the yellow, 4x minus 8 with the pink. So to figure out what x is, right, I got to think about what those two pieces of information can be set up as. Those look to me to be two different parts of a diagonal. We know that the diagonals are cut in half, right, which means that those two sides are the same. So that's telling me is that AE, this 2x plus 2, is going to be the exact same thing, right? We can say that it's equal to 4x minus 8. Right? After that, honestly, that's all the geometry part of it, right? After this, it's just an algebra problem. Right? What I'm going to do is I'm going to move all my x's over to one side. So I'm subtracting 2x to move that over to the right. I'm going to add 8 to both sides to move those over to the left, right? Remember that you want to move your variables and your constants to opposite sides from each other. And last but not least, I need to get rid of that coefficient in front of the x. Right? So that 2x is 2 times x, so to get rid of that, I divide. Alright, so I'm going to get that x is just 5. Right? Some of the problems may have you then like, oh, find AE and find EC. All I would do is say I wanted to find out what AE was. Right? I know that AE is 2x plus 2. So what we're going to do is we're going to plug that 5 in where I would have had an x. All right, 2 times 5 is 10. 10 plus 2 is 12. What you could do to check your work every time you do one of these is you could plug it into both of them and make sure that they do come out the same. Right? If I can see that if I plug it in for EC and I have 4 times 5, which is 20, 20 minus 8 is 12, the fact that they match means I did everything right. Right? If you check your work that way and you find that something doesn't match that should, you might want to go back and check your math again. Right? So the fact that the diagonals bisect is what allowed us to set up that problem that way. For this one, we've got that the measure of angle ABC, right? So this angle down here is 10x plus 6. And the measure of angle CDA, right up there, is 2x plus 30. All right, so 2x plus 30 is the pink, 10x plus 6 is the yellow. So again, we're trying to figure out how can I set this up to find x, which is what it's asking for. All right, so I'm taking a look and I'm saying, all right, what's the relationship between those pieces of information? On this one, they're opposite angles. When I have two opposite angles, I know that I can set those measures equal because they should be the same thing. So I'm going to say that 10x plus 6 is equal to 2x plus 30. And again, now it's just an algebra problem. Right? I'm going to move my x's over to one side. And then if it's okay with you guys, I'm going to move my 6 over to the right at the same time. Save a little bit of space. Alright, so I move those x's over there. I am moving my constants over to the other side. That'd be 24. And last but not least, we divide to get rid of that coefficient. So I'm going to get is that x is just 3. Right? And again, if I went ahead and I plugged in 3, I should get the same thing for both of these. Right? As I'm kind of running it through my head, if you plugged in 3 for x on both of those, they'd both come out to be 36 degrees, which is great. Right? We want them to be the same thing. All right, but again, the opposite angles being the same is what allows us to set it up at first. So this one's kind of a two-parter. Right? What this one's asking is, should AB have the same slope as DC? All right, so let's take a look. Right? AB and DC. Yeah, I think so, right? Because part of being a parallelogram means that they have parallel sides. Right? We have two pairs of parallel sides. So what we're going to do for this problem, right, is we're going to work on off of the fact that they are parallel sides. What it's telling me is about angle ACD, which is this angle down there, and angle CAB, that angle up there. All right, so the tricky part here is trying to figure out, like, how do those relate to each other? All right, well, we just talked about how these sides are parallel. All right, the fact that those sides are parallel allows me to talk about those two angles that I marked up with the red as alternate interior angles. All right, so pulling some knowledge from deep within your brain from geometry A, when we have alternate interior angles, their measures are the same. So I could say that 3y plus 2 is equal to 5y minus 4. Right, and again, after we get things set up, it's just an algebra problem. Move my y's over to one side. At the same time, I'm going to move my constants over to the opposite side from that. And get that 6 equals 2y. Divide everything by that coefficient to get rid of it. You get that y is 3. And again, same thing as what I've been saying on the last couple. The fact that we set these up equal to each other means that if I plug that 3 in for y in either one of them, they should come out to be the same thing. All right. Whew, we're almost there. So, on this one, we're talking about the measure of angle ABC, right? This angle down here. And we're also talking about the measure of angle BCD over in that other corner, right around the corner from it. What it wants us to do here is it wants us to figure out what y is. Right? So to figure out what y is, I have to think about what the relationship is between that yellow and that pink angle. So when I'm going through the yellow and the pink one, right, I'm noticing that they are consecutive angles. Right? The fact that they're consecutive means that they are supplementary. Right? So like we talked about a little bit at the top of this, right? If they're supplementary, that means that when you add them together, right, so 3y plus 2 plus 5y minus 4, that they come out to be 180 degrees altogether. And so all I'm going to do here, right, these things are all on the same side right now, right? The 3y and the 5y, the 2 and the minus 4. So we're not doing any sort of opposite stuff, right? We're combining like terms. So 3y plus 5y gives me 8y. I've got this plus 2 and this minus 4 on the same side, so it's going to come out as minus 2. Right, and that'll give me 180 degrees total. Ew, I don't think this is going to come out very well. So what we're going to do here is we are going to add 2 to each side. All right, so we get that 8y equals 182. All right, so I'm going to grab my calculator real quick because that one's going to come out kind of nasty. 182 divided by 8 is going to give me that y is equal to 22.75. Gross, right? Could be worse though. Could add a bunch more decimals there. Right? But at the end of the day, right, what that means is that if I plug in 22.75 into each of those, right, they should give me two angles that when added together give me 180 degrees. Right, so again, we're just working off the fact that these consecutive angles have to be supplementary and add to 180. That's what allows us to set things up. All right, got a little tiny bit left to talk about. Sometimes when we're talking about parallelograms, right, we might not have every last bit of information. So we have what are called sufficient conditions for parallelograms. So you might remember when you talked about triangle congruence at the end of geometry A, right? There were some things that like, oh, if you have at least this much information, you can say that the triangles are congruent to each other. That's kind of similar, right? If you have at least this much information, you can say that your shape is a parallelogram. So if in a quadrilateral we have one pair of sides that are congruent, right? So let's choose these ones. Right? If these sides are the same size and they're parallel, right, then that's enough to say that that's a parallelogram. Right? And it doesn't even have to be those sides, right? I could have that those two sides are the same size and parallel. Or I could have that these two sides are the same size and parallel. Right? As long as you have one pair of sides that are that, then it's a parallelogram. You could also have that both pairs of opposite sides are congruent. Right? So you could say they're like, oh, this and this are the same size, and so are these. If you have that, then that's also going to have to be a parallelogram. Right? So again, we don't have everything marked, right? But that's enough to be able to say that it is a parallelogram. If we have that the diagonals bisect each other, right? Let's see how well I can draw diagonals compared to Miss KB. Oh no. Wow, that sure looks like a straight line. Looks pretty good to me. Let's see if I can make another straight line. I know that was challenging on hers. Wow, look at those. Look at those straight lines. So those diagonals bisect each other. Right, so I've got those diagonals, and they're getting split in half by that middle point where they meet. And so if you have diagonals that bisect, then it's a parallelogram. Last but not least, if you're just trying to get to being a parallelogram, you could have that both pairs of opposite angles are congruent. Right, so we're talking about opposite angles, right? So that one and that one are opposite. They have to be congruent. You can also talk about these kind of tiny ones on each side. These two would have to be congruent, right? So if you have at least this much information, right, you could choose any one of these four. If you've got a situation of one of these four, then it's definitely a parallelogram. Right, down at the end of here, it's kind of a little bit of a recap of the video that Miss KB did on the quadrilateral family tree. Right, you're going to have that the diagonals bisect each other in parallelograms, rhombuses or rhombi, whatever the plural is, rectangles, and squares. Right, so these are all the types of quadrilaterals where the diagonals will bisect each other. The diagonals are going to perpendicularly bisect each other in kites, rhombuses, and squares. Right. We're going to know that both parts of the diagonals are congruent in isosceles, trapezoids, rectangles, and squares. Right. And that's going to wrap it up for this one. I would double check on Google Classroom, make sure you know what you need to do, and I'm out.